Welcome to a Supply Chain Institute online resource. Dashboards are a major flexing feature that allows you to summarize, transform, and present information from your model to really make your project shine. Back in the day, graphing started out as simple 3D objects you could place on your 3D view, the only workspace we had available at that time. The simulation engine has come a long way from then. Now we have, of course, the 3D view, we have the process flow, we have graphical user interfaces and dashboards. Dashboards. They allow you to use literally dozens of prefabricated graph templates to record KPIs or key performance indicators as basic as inputs or outputs, or display your cycle times, state times, resource states, inventory levels across time, and things much more complex. Dashboard elements can be added by dragging them from the library or pinning as statistics from an object. Dashboard elements can gather their data directly from a table or calculated table or from a statistics collector that can basically listen to any event happening in the simulation. This is really simulating the supply chain, where we will dare to take a deep dive into the wonders of simulating, experimenting, and optimizing the supply chain. The course is structured in 5 blocks, the first by focusing on the DC. Okay guys, so let's do a recap. So now we've added variability to our picking process by either picking or not a particular SKU, and then by changing the amount of boxes that we're picking per SKU with these tables that we're using right here. So now we're going to add our first dashboard, and we want to capture some information in a graph. And one particular KPI that is very important for picking is the cycle time. So in order to record that, we want to know when we started that picking cycle and when we ended. So to do that, let's add an assign label activity right here before starting the picking process. Let's name it properly. We're going to add it to token. And the way that we can reference or get the actual time of the model is just by pressing or punching in this command right here with void parentheses, and it's going to get the time of the simulation. So that way we're recording the start time, and we want to record the end time, and we can do it right here. Use the same command. Let's just test that. We might do that just by clicking on the token, seeing if the values are changing. Let's look at that. Perfect. There we go. So now we have when we started, when the cycle ended. Next we have to record the time that elapsed between those two moments in time to record the duration of the picking cycle. And we can do that by adding adding that value to, I'm thinking about a table, and where we can record each of the cycle times so that then we can compare them. So 80, 11 time, and I'm gonna specifically state that we have a table right there because it will help me later on. So go to your global tables and add a table, guys. We're gonna name it cycle times. We're gonna be that specific, and here's the point where we're gonna record the actual time. And I want this table to be new and fresh every time we start. So it's gonna delete all rows. So every time I press reset, it's gonna clear it. And the way to record that value is to, and there's a command specifically to do that. We add a row and data to a global table. We're gonna choose the table we just created, and we're gonna do a subtraction, which is basically token dot end time end minus token dot time start, and we're gonna divide that by 60 because we don't want any seconds. We don't want the data in seconds, but the report should be in minutes. It's easier to understand. Let's see if it happens. Great. So now we have, even though we have fixed process times for picking up the box and putting it on the mixed pallet, we do have variability in our picking process. So it reflects on the actual cycle time. We want to add that to our dashboard. So in order to reflect this information in a graph, we first need to prepare the data, and we do that by adding a calculated table. Please do that. The name that I'm going to use is cycle times calc. So it's with the name at first glance, I know that it's the same information, but this one uses a calculated table. I'm going to use the cycle times table, of course, and the matrix is going to be a single column called cycle time by using that column, and we're not going to be adding a new column. We're going to use that same column. Let's go see the calculations. Don't worry, Flexim uses SQL. We're not going to learn SQL for now. Eventually we're going to do that. Let's update it. If that updates correctly, that means that it's catching the values from the original table, and it's doing it correctly. So go ahead and graph it. I'm gonna go for the base chart, which is called a histogram. For you guys who are not don't have that histogram concept fresh in your mind, according to our friends at Wikipedia, I found a pretty useful definition here, pretty straightforward. It says that first you have to create a bin or bucket with a range of values, and then count how many values fall into each interval. Remember what we did with our triangular distribution? If you see this sequence, this is exactly what a histogram does. It records how many events fall into a particular category. So now let's use a very explicit name, because this is going to be visible for your audience, whether it be your boss, your customer, your team. So let's call it picking cycle time histogram. The data source is going to be that calculated table. As the values, we're going to use these values, and let's show the labels so we know the actual values. And as a title, we're going to say cycle times in minutes, specifying the units. Everybody's going to ask, in what units are those graphs? And the y-axis is going to be the frequency. Oh, if we press OK and apply, it's going to actually refresh the values that we have in that, or we will have in that graph, and see how do we interpret this table. How do we interpret this table? We say there were two orders that took from 1.04 to 1.16 minutes to pick. there was one order that took more than 2 minutes to pick, and there were 2 orders between 1.5 and 1.62. That's the way you interpret this graph. So if we run it again, there's something that we haven't changed in our calculated table, is the frequency that it's going to be refreshing the values. Instead of being a manual, let's set it as always, and that way you're not going to maybe confuse one run with another. There we're dynamically graphing our cycle times, so it's perfect. So then the last item that we wanted to review today is maybe look at some possible picking routes and comparing them. And it's very easy. What we're going to do is, for example, let's add an additional KPI right here. Let's add. I want to add, for example, the average cycle time for our process. There could be plenty of ways to do that. I'm gonna add a table called cycle time average, and I'm just gonna use one row, one cell actually, and it's gonna update over there. But I do want to clear the cell data every time I click reset. For example, when I have this value, I reset it, it goes back to 0. That's okay, that's exactly what I want to do. Go to, right after we added that cycle time to our table, is a perfect opportunity to update the average cycle time. So for example, we add one activity, a command right here. We're going to write it to a global table. It's going to be the cycle time average, and it's always going to be row 1, column 1. But here I want you guys to do something like this. Let me see. We're gonna want to edit the code directly, because I don't think that there's another way of doing it. I haven't seen it, at least in the all the friendly graphical user interfaces that we have there. What we want to do is update row 1, column 1 of our table that's called cycle times average with a value, but that value is not going to be 1. So right in between these two code rows, I'm gonna ask you guys to add or write down this code that's specifically stated down here. And I wrote this code. You can pause the video and write it down, guys. And what I'm explaining, or the command here, is I create a variable called table cycle times, which is a table type, and it references, of course, my cycle times table. And then I'm gonna create a second variable called cycle time average, which is a double because it uses decimal points. If you want to know more about data types, you can go to the reference manual. I also included some examples, so when you use them, you can refer to these examples to identify the possible syntax. But remember that everything can be found in the user's manual, the documentation that comes along with Flexim. In Flexim, we have visited a couple of those, and today we're using table and double. So this value that contains decimal points, we're gonna use this command here that says get the mean in the rows, in all of the rows, like counting or using all of the rows, the values of the rows in the table, and visit each and every one of them, but the value is going to be on the first column, because remember that table only has one column. And the value instead that we report to the table, instead of being 1, is going to be exactly this variable that we're getting, that we're calculating. That means that every time that we record the value in the table, then we're gonna calculate the average and place it right here. I don't know how it's gonna behave with just one value. It behaved pretty decently, no problems. So I wanted this value because I want it in my dashboard, and the way I add it is I click on the cell and I pin it to my dashboard, to my dashboard, as a table of values. Right there. Instead of using table of values, let's call it picking summary. And right here we're gonna say, okay, this variable right here is called the average cycle time. There we go. That was a trick, right? Just average cycle time. So whenever we are running the model, it's gonna be updating. It's gonna be it's called a hot link, because it's continuously updating. And we know the average. We know how all the different cycle times behave. Next, what are other variables that we might want to know or record from the picking process? Maybe the amount of boxes that we picked, right? We want to update that. We can, the name for this table originally was cycle times average, but it is very likely that I want to call it KPIs, because I'm going to use more than one value. Let's just be sure that it's referencing the right table. I think the reference here is okay, but I just went over here, and the second command here, it references the name that I had stated previously. Now I'm going to change it back to KPIs because I changed the name. That's out of the pull down menu. I can choose the right table. And this time it's going to be boxes picked. And we want to add SKUs picked, or instead of SKUs, the right logistics concept is lines picked, and orders picked. There we go. I'm going to write to a global table called KPIs. It's going to be the second row. And I'm going to increment it by 1 unit. Now we will add the same for SKUs to count the lines. Every time a new SKU is being picked, we're going to increment that cell of the table by 1 unit. And we will repeat this process for the orders. We want to count each and every one of the orders that's being fulfilled and make sure that we record that additional order in our table. Because we already have a custom code here, we didn't need to add an additional activity. We can add an additional command in the same activity. Let's try it. We would expect those numbers to increase. Yes, perfect. It is recording the different indicators that I wanted to track, which is the number of boxes, number of lines, and number of orders picked. Oh no, I can't believe it. My spelling was wrong. Histogram uses an I, not a Y. I'm sorry. If we want to identify the most efficient route, and what I mean by that is, for example, try this one. We're going to call it the snake pattern. Remember that we have the empties, and the empties are always going to be on the first location we're going to visit. Next, I'm going to delete all the center locations. And I'm going to minimize this window. And next, I'm going to use the S connection to connect in the sequence that I want to try. For example, the first one would be this one. Second one. And once we're done, we want to make sure by clicking on the center port label here that it refreshes the contents, and we see that we have 9 locations, or how many locations you guys have on your simulation. 2, 4, 5, 8 plus the empties, that's 9. That's okay. That means that we have connected to all the locations of the products that we want to pick. I say okay, and remember, it'll visit the locations in the sequence that I have connected. So look at what's going to happen. Did you see that? It's visiting locations in a different way than the horseshoe route. The snake route, if it's picking, the items, it's gonna do that. There you go. Now we can see how effective it was, or how efficient it was, by identifying, by looking at all the orders and looking at the average cycle time. So we will be comparing cycle times among all the options that we have there. Let's keep this somewhere safe for later. Is one run enough to get conclusions out of this simulation? Probably not. We're going to talk about replicas later on during the course. Let's try our zigzag distribution. There we go, nine ports. Now I'm gonna run it again. Let's get these forklift out of the way. Let's keep this somewhere safe for later. And finally, I'm going to compare the horseshoe pattern for the picking route. Here we are. Let's keep this somewhere safe for later. And well, I guess it is finally time to compare the performance of our 3 route designs. I really won't expect anything from comparing an 8 SKU picking route for obvious reasons, but please identify the elements available to you with these results for decision making. You can see that different behaviors of the 3 routes, and of course this variability can also be attributed to whether we're picking the SKUs or not, and the variability of the amount of boxes. But what I'm trying, and it is probable that we would have to run each of the models at least a couple dozen times, maybe a dozen times, and so we would have enough information to say if really the average cycle time for this one was 1.4, the same for this one, the same for this one. Eventually we'll reach the point where we will be running simulation replicas and simulation scenarios, and we will learn all the principles behind actually doing that. It's not as simple as just comparing one run, but it serves the purpose that I wanted to show you guys, that you can change your picking route just by changing the connections, run it, and have a very, very quick comparison of the results. Just to show you two things: the flexibility of the model, that it doesn't need any additional complex configurations, and the second point is, of course, your KPIs and your histogram. Very visual, very nice tool as a dashboard, and you just configured it in a couple of minutes. So I'm gonna give it up for you guys, because this is the second model that you complete, and now it's time for you to go ahead, make a great effort to complete the assignment, or how we call it, the problem set that we put together for you to test your actual simulation capabilities and skills. I hope you have really acquired some skills and craftsmanship here. Remember, I'm gonna continue creating new videos for the distribution center processes, and then we're gonna jump to some other stuff like the yard and some other stuff like tactical scheduling and things like that. But I'm gonna make a bonus video, an additional bonus video, where I'm gonna put together the inbound and the outbound layouts and processes, and they're gonna work together. I'm gonna release that in the web page for you guys to pick up and use. It's gonna be huge because it's gonna have multiple inbound doors, multiple outbound doors, the picking process integrated with the inbound, and it's gonna be great. So that's gonna be available for you guys to use. in case you have a FlexSim license, you can make it bigger. You can change some additional configurations, and if not, you can just load the order profiles and the inbound profile, and there you go. You can run a simulation with the existing model. So thank you guys for being here. Let's keep in touch. Please sign up for the notification so you don't miss out on our next video. We'll be releasing 2 videos per week. Thank you for being here. This is block number 1, this really simulating the DC. This is Really Simulating the Supply Chain, a free online resource for industry professionals. Cheers!